Back, everybody. So let's apply some of our newly found logarithmic skills. And we're going to start with compound interest. And simple interest is here. This is literally the interest that's earned, is the principal times the rate times the time. And simple interest, if you have $100 in the bank at 5%, you get $5 every year. That's for as long as you leave it in there. Compound interest is a little bit more involved. So after year one, if you had a principal of $100, and we're going to assume we're at 5%, just to keep it simple, you get $5, giving you a total of $100 plus $5 equals $105. Now, for year two, that's your new principal. Simple interest, it's not, it's always 100. So we're now at 105. So now I'm going to earn 5% on the 105 instead of just the 100. So you can see it's literally compounding. So 105 times 0.05. So this is $5.25. So you made 25 cents more than you did the previous year. So your total is 105 plus $5.25. You have a total of $110.25. So year three, you now have $110.25 in there. 10.25 times 5%. So now you're making $5.51. So that means the total is going to be 110.25 plus $5.51. It's going to give us a total of $115.76, and so on. So hopefully you get the point on that. The formula for compound interest, N, as you see in the formula, is the number of times that it's compounded per year. So if it says it's compounded annually, that means N is 1. Compounded semi-annually, that means N is 2. Monthly, N is 12. Quarterly, N is 4, and so on. Daily, be 365, and so on. So this is compounded N times per year. This formula comes from here, is when it's compounded continuously, meaning there's no breaks. It's always being compounded. And it sounds like it's going to be a lot more. It's not really a lot more. It's a little more. Let's give it a shot. So let's try one. Part A. $300 invested at 7.5% for 4 years, compounded quarterly. So we're using this formula here. In this case, P is 300. The rate is 0.075. We have to convert the percent into a decimal. The amount of time is 4 years, and N in this case, because it's quarterly, is going to be 4. All right, let's drop in. So we have there. So we have that A is equal to 300 times 1 plus 0.075 divided by 4. Raised to the 4 times 4 power. Now, it's careful. We need to follow order of operations with our calculators here. So we're going to start inside the parentheses. And inside the parentheses, we're going to do the division first. So 0.075 divided by 4 plus 1 raised to the 16th power, and then times 300. You may want to practice with your calculator several times just to make sure that you're real comfortable with your particular calculator. So this is about $403.83. So after 4 years, you've made about $103 profit just from letting your money sit in the account. Now part B is going to use the other formula. We're going to use this one here. So $500, that's P, invested at a rate of 0.067, 6.7%. T is 6. It's compounded continuously, so we're using this formula here. A equals P, this one here, 500 E to the 0.067 times 6. Now, I can do E raised and I can multiply it in my exponent. You may need to use parentheses, E raised to the, and make sure that you get all that. So you have to practice with yours. It may not look, the interface may not be the same as mine. So to find E, I have to do exponents first. E is above the LN button. You see way down here at the bottom. And so because it's blue, I have to hit the second and then that. E to the 0.067 times 6. Now, this is the part where your calculator may do this a little bit differently. If it doesn't make an exponent like that, just make sure that you keep it in parentheses. There, and times 500. $747.41 looks like to me. Moving on. All right, compound interest part 2. Sounds very dramatic. On January 2nd, 2007, $3,000 was placed in an IRA that will pay an interest of 7.5% per annum, compounded continuously. All right, so part A and part B I have removed. So what will we do? Okay, so let's figure out how many years this is. Sorry, P is 3,000. 2007 to 2022. So 2022 minus 27. That's 15 years. So T is 15. And it's compounded continuously. We have R is 0.075. And we are going to put that in there. Let's do this. The total amount is going to be 3,000 E to the 0.075 times 15. Show this second ln E to the 0.075 times 15 times 3,000. Wow, that's a lot. Of course, that's 15 years, right? 9,240. You should be doing this with your calculator, double checking my numbers. 65 cents. All right, find the principal needed now to get each amount, that is, find the present value. So part A. So we want $2,000, so that's A. And compounded daily. So we're using the other formula. N is 365 in this case. So we're using this one here where N is 365. So this is 200 is equal to P, which is what we're looking for. 1 plus 0.05 divided by 365 raised to 365 times number of years, 3 years. I'm going to get that number real quick. 365 times 3. So 1,095. I'll come back to that. So let's do some fancy tricks here. So I'm going to get what this is. Then I'm going to go 200 divided by that answer. And I'm going to use the answer button. You can see it above my negative here. So let's do this. So 0.05 divided by 365 plus 1 raised to the 1095 power. 1095 power. All right, so I'm going to go 200 divided by that number. So 200 divided by, and to get the previous answer, I can hit second in the previous answer. That's going to put that 1.16 and so on, all those digits in there, so I get as accurate as I can. And it looks like $172.14. Actually, to guarantee that, so P is going to be about $172, and we'll round it up. 1.5. It'll guarantee us that $200 after 3 years. Part B. So now we're using the Pert formula. That's continuously done. Here's continuous. So we have that, and again, we're looking for P. So A in this case is 1,000. P, e to the 0.07 times 5 is RT. So there's R, there's T. And I want to point out that 0.07 times 5 is 0.35. So just keep that in mind. That's going to be the exponent. And you know what, we can actually write it out. Divide both sides by e to the 0.35. I get P is going to be 1,000 divided by e to the 0.35 power. Let's see what that looks like. 1,000. Divided by second ln, which is e to the 0.35 power. There. So this is about $704.69. Lastly, how long does it take for money to double at 4.5%? Compounded quarterly. So let's start here with part A. So money to double means A is 2 times the principal is what that means for money to double. So using the first formula, by the way, this means N is 4, right? A quart, like a quarter, or cuatro in Spanish. All right, so we are going to get 2P equals P times 1 plus R is 0.045 and is 4 raised to the NT, that's 4T power. And I'm going to notice that when we have this, we can actually divide the P out. So this is 2 equals, and let's figure out what that is in there. So 0.045 divided by 4 plus 1. So we have all that going on there. So this becomes 1.01125 raised to the 4T power. Now, what I'm going to have to do is take the log of both sides to get that T down. So I'm going to do ln. You can do common log, doesn't matter. And when I do the log, that gets to come down 4T ln of 1.01125. And I'm going to divide both sides by all of this. This is 4 times 1.01125. Giving me that T is going to be that. So let's be real careful with this. ln of 2, ln of 2, do that, divided by, now I'm going to put all this in parentheses because I have a couple things down here. So this is going to be 4 times the natural log of 1.01125, giving us about 15 and a half years. So t is about 15.5 years. All right. Now, once again, because it's continuous, I'm using the Pert PEDRT formula. So A is 2p again, p e to the 0.045 t. Once again, the p's reduce out. Meaning the initial principle is irrelevant. 2e to the 0.045 t power equal. And I'm going to convert this into logarithmic form. E is already here, so I'm obviously going to use ln. So this becomes 0.045 t equals the ln of 2. And let's see what we get. So ln of 2 divided by 0.045. So about 15.4 years. Not a big difference. A little faster if we do the continuous, but again, it's not like off the charts. So I hope that helps.